Both the waiter and the cook functions are transformed when we put the async keyword in front of their definition. From that point on, we call these functions coroutines. If you try to execute a coroutine directly, you will get a coroutine message, but the code won't be executed. We can try that out by running a Python shell and importing the cook function from the coros file. First, comment the async io run command so that the code isn't executed and save the file. Then open a Python terminal and type the following commands. Coroutines can only be executed using a running loop or awaiting on them from another coroutine. There's a third way we can execute a coroutine, and we'll see how to do that next. We can run multiple coroutines by using tasks. So go ahead and copy the coros.py file into a file we'll call tasks.py and write the following code. What we're doing here is creating 3 tasks with the different orders. Tasks give us 2 benefits that we don't get when we just await an expression. First, tasks are used to schedule coroutines concurrently, and second, tasks can be canceled while we're waiting them to finish. So in the above code, when we await the 3 tasks, the 3 cook coroutines are running at the same time, so the execution is quite different. Go ahead and run the code. This looks more like what we were expecting. The waiter puts all orders one after the other, and the dishes that are quicker to prepare, completed first by the cook.